Am I audible to all of you?
Yes, sir.
Okay.
Yes.
Wait, my laptop is hanging a lot. Wait, just give me a minute. Okay, so let us start. Can you see my screen? Can you see my screen? So in the last class, where did we stop? Can anyone say me?
Yes, sir.
So it was a brief introduction, right? In the last class. Yes or no? Please respond, anyone? Am I not audible?
Sir, it's audible. We can hear it.
My voice is not cracking now. Is my voice cracking?
Yes, sir.
कि मेरा
No,
voice थोड़ा
sir.
break
It's
हो रहा
not
है
breaking,
क्या?
sir.
हाँ हाँ क्या क्या बोला? Crack
Sir,
crack
it's
हो रहा है
not
क्या?
breaking.
Crack हो रहा है क्या मेरा voice?
No, sir.
No, sir.
Okay, okay, okay then. Okay. So now let us discuss. First of all, in the last class, I think so you discussed regarding concept of stress. Huh? So now we'll go to the next part. You can see what is stress actually. So suppose, can you see the screen? I hope all of you can see the screen. I hope all of you can see the screen.
Yes, sir.
Yes, sir.
So what is stress actually? Suppose let us consider a rectangular bar of some cross section subjected to some load force. Okay, now this is the force suppose, and this is the what cross sectional area. So now stress means what? Now you can assume that let us imagine that some same rectangular bar is assumed to be cut into two halves at section XX. And that each portion of the rectangular bar is in equilibrium under the section of load P, and the internal forces acting on the section XX has been shown. Now look, the rectangular bar is what cut in this section because of the implementation of this force P. Now we just saw this is the surface area that we have to consider. This is the surface area that we have to consider, right? So now if we have to consider this surface area, then the stress, the stress is what defined as the force. The stress is denoted by what? Sigma. Sigma is equal to what? P by A. P by A means P is the force, A is the cross sectional area. Fine. Any doubt? Any doubt?
No, sir.
Okay. P is the force, A is the cross sectional area. So now what will happen is we are assuming here that the total force or the total load that is carried by the rectangular bar, this is uniformly distributed over the section. That is why we can just, that means the force, this force P, though we are showing it from a single point here, but this thing is what assumed to be acting uniformly like this. Is it okay? Is it clear? So that is why we derive this expression. Okay. Now if the force carried by a component is not uniformly distributed over its cross-sectional area, then we must consider a small area, right? That means the small area should be what? dA. And which carries a small load dP. dP is the load of the total force Q. Then the definition of stress is delta F, sigma equal to delta F by delta A. Why delta F by delta A? Because we are considering a very small amount of the force, nah? That is why delta F by delta A. Now this stress sigma, if you are considering a very small area, then you all know limit delta A tends to 0, del F by del A. So delta A tends to 0 means what? The area is extremely small. That is why this one. That is why this del component has come, because of this limit. Okay. Now the basic unit of stresses in SI units are Newton per meter square or Pascal. Just remember this thing. This is a very important thing. The basic unit of stress. Now the basic unit of stress is in SI unit what? Newton per meter square or pascals. Means 1 Newton per meter square equal to 1 Pascal. Is it clear? Is it clear, everyone? Just keep on
Yes,
responding. Is
sir.
it clear? Okay. Just keep on responding when I ask you something. So this is what the stress is. Now, look, for smaller amount of stresses, it is okay. Like we are getting it around. We are getting it like in this manner. Like what do you call it? Pascals in that units. But for larger unit, if you can see the screen, for larger units, what happens? We will be having need to use what? We will be required to use a more larger value, no? Yes or no? Yes or no? That means we'll be having what? Megapascal, then gigapascal, okay, then kilopascal. Now this megapascal is MPa, okay, megapascal. That means 10 to the power 6. Just remember one thing, never forget 10 to the power 6 Pascal means mega, okay. Then you are having what? Giga. Giga is 10 to the power 9, okay. Then you are having what? Kilo. Kilopascal is 10 to the power 3. Now, this megapascal, is equivalent to what? Newton per mm square. If you can see here, Newton per mm square means what? Megapascal. Just remember, never forget, Newton per mm square or megapascal is same. Fine. Now, if you go to the next one, types of stresses. What are the different types of stresses? The different types of stresses are normal stress. There are two basic types of stresses that exist. Okay. So basic type of stresses that exist is normal stress and
Sir.
shear stress.
सर
बोलो बोलो।
सर लॉबी पे एक वो स्टूडेंट रुक रहा है सर। अब ठीक है।
अभी ठीक है? अभी ठीक है?
यस सर। यस सर।
अगर रुकेगा तो ऐसे बोल देना तुम लोग, मुझे ये नहीं होगा ना, मुझे पता नहीं चलेगा ना।
जी सर।
हाँ, और तुम लोग का दोस्त लोग को बोल देना वो 5 मिनट बाद एंट्री मत कर,
जी
मतलब 5 मिनट के अंदर एंट्री करने को। अभी सब लोग एंट्री कर रहे हैं।
जी सर।
Types of stresses. What are the different types of stresses? There are only two basic types of stresses exist, that is normal stress and shear stress. Right? Now, there are certain other stress. Now, this look, other stresses that are similar to these basic stresses are a combination of these. That means the normal or shear. These are the two main stresses. Now, apart from these, if you see bending stress, if you hear this term, then this is a combination. What? This is a combination of tensile, compressive, and shear stress. Okay. Now, tensile and compressive part comes under what? Normal, and shear is always there. Now, torsion state is a shearing stress. So these are all combinations. Now, let us define one thing: normal stress. The normal stress is defined as what? Force per unit area. That means what? If the stresses are coming in the normal direction to the area, huh? In the normal direction to the area, then what you call is, it is called as normal stress. Okay. Now just pay attention. The stress is forced by an area. If the stresses are normal to the areas concerned, then these are termed as what? Normal stresses. The normal stresses are generally denoted by Greek area S. Now look, or you can say sigma. Greek letter S means what? You can say it as sigma. Fine. Now these are normal stress. So what is basically normal stress? Now look, this is the area. If you can see here, this is the area in this figure. Right. Now if this is the area, hmm, then this is force per unit area stress, right? So this is the stress. So this is coming perpendicular to the area. So if this is coming perpendicular to the area, then we'll call it what? normal stress. Okay,
Your voice is not clear.
my voice is not clear.
Yes, sir.
Yes,
It's
sir.
not clear.
Yes, sir, it's breaking.
Yes.
Okay, thank you. Wait a minute then. Network is not good. Wait. Give me a minute. Is it breaking now also? Is it breaking now also? Is it breaking now also?
Sir, still it's not clear.
Still it's not clear. Is it clear now?
Yes, sir.
Is it clear now?
Yes, sir.
Yes, sir.
So if it is not clear, then let me know, huh? Okay. Is it clear now? I think so. It is clear now.
Yes, sir. Yes.
Okay. Tell me, huh, again if it is not clear. Okay. Now listen.
Okay, sir.
So where did we stop? Yeah, normal stress. So did you understand the term normal stress?
Sir, again it's breaking.
Again I am lagging. Am I lagging again?
No, sir.
No, na?
Yes.
What? Tell me if I am
Please
lagging.
explain
Yes.
again, sir.
Uh-huh. What did you say? फिर से मेरा वॉइस ब्रेक हो रहा है क्या? Am I lagging now also?
No, sir, not clear.
Here.
Sir, it's becoming worse.
It's becoming worse. Huh? So normal stress. Normal stress. Did you understand or shall I need to explain it again? Normal stress. Did you understand or shall I need to explain it again? Hello. 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 Can you hear me now?
Yes, sir.
Yes, sir.
So did you understand normal shear, normal stress and normal stress, or do I need to explain it again?
So it would be better if you explain again.
Okay, fine. I'll explain it
Explain,
again.
sir.
Fine. I'll explain it again. So what is normal stress actually? Now look, we have defined shear stress as force per unit area, right? Now stress means what? Force per unit area. Now if the stress is force per unit area, then
this force that is acting perpendicular to this area. Suppose this is the area, right? Now the force is what? It is acting in this direction. Now this is perpendicular to this area, right or no? Yes or no?
Yes, sir.
So if this is acting perpendicular to the area, then what will you say? That this is normal stress. Okay, and this is also known as uniaxial state of stress because stresses act in only one direction. Why uniaxial? Because the stresses is acting in only one direction, be it in this direction, be it in this direction. Okay, now, but in practical cases, this is not relevant because in practical cases, we have so many stresses that are acting in so many directions. Fine. So this is actually a practical state. Now, this is what? This is a biaxial state. Biaxial means what? These are acting in two directions. In this direction, in this direction. Okay? In this direction and in this. That means what? In biaxial, it is only x and what? Y axis. Got it? But in triaxial state of stress, this is triaxial state of stress. It will be acting in what? X, then you come Y, then you go to Z. Huh? These three axes, no? Is it clear now? Biaxial and triaxial state of stress.
Yes,
Is it
sir.
clear?
Yes, sir.
It's clear.
Okay. I think so. My voice is clear. And CR, please inform your batchmates that not to join the classroom after 5 minutes. Okay. Please ask them to join at the given time.
Okay, sir.
Then tensile or compressive stresses. So what is tensile and what is compressive? If you see the figure, the stresses can either be what? Compressive or tensile. Now in tensile stress, what will happen? Suppose this is the box. You are pulling it. If you are pulling it in both the directions, then it is what? Tensile. That means what? You are giving tension. Similarly, in compressive means what? You are compressing it, or you are just pressing it towards inwards. So this is known as tensile and compressive stress. Fine. Now we'll go. What
Is
is
it possible that tensile stress can be used in the
it is possible what?
XYZ
समझा
compression?
नहीं समझा नहीं मैं बोलो तो एक बार फिर से.
Is it possible that the tensile compressive stress can be used in the tri-direction stress like XYZ?
Obviously. Look, here this one is what? This is in this direction, na? देखो, you are pulling it from this side, right? So this is what? Tensile. Now if you are pushing it from this side, then it becomes what? Compressive. This is T. Understood? Understood?
Yes, sir.
यही था ना तुम्हारा डाउट?
Yes.
हाँ?
हाँ सर ठीक है ये.
Okay, good. You should ask questions. Then you go to the next bearing. Bearing means what? It's simple. When an object presses against each other, एक ऑब्जेक्ट दूसरे ऑब्जेक्ट को प्रेस कर रहा है, then it is called bearing stress. Okay? Look, this is an example of bearing stress. So this is the object, this is the soil surface. Now this object is pressing the soil at this point, right? That means what? The bearing stress will be exerted here at this point. Clear? Now we'll go to shear stress. The previous part, is it clear?
Yes, sir.
Okay. दो मिनट रुको. I'm showing you a video to clear your concepts. Can you see the screen? Can you see the screen?
Yes, sir.
Yes, sir.
Okay. So,
in physics, we could say that the cake experiences stress. Usually, when we cut a cake, we hold the knife straight and apply the force perpendicular to the surface area. So, can you guess what type of stress this is? It is normal stress as the force is acting perpendicular to this area. But what about these cross-sectional areas of the cake? The area on top is not the only area that experiences stress. As we pierce the knife in, this cross-sectional area experiences stress too. It doesn't look too obvious, but it does experience stress. We can also see that the force is not perpendicular to this area. It acts parallel to it as we are pushing the knife straight down. If the force acts parallel to the surface, it exerts shear stress. This stress tries to push the two surfaces away from each other and hence results in plastic deformation. So this is the basic difference between normal stress and shear stress. Normal stress is where the force is acting perpendicular to the area of contact, while shear stress is the force that acts parallel to the area. Let's take another example which explains shear stress better. Here's a beam and assume that it's fixed at its base. If we apply normal force to this cross-sectional area, then we know that the stress experienced by the beam will be normal stress, which is simply given by F over A, where F is the applied force and A is this cross-sectional area. This will result in a normal strain in the beam, which is given by delta L over L, where delta L is the change in length and L is the original length. Now suppose that we apply a force in this direction, parallel to area A. Again, the beam will experience some stress, but this time it will be a shear stress. The equation or formula for shear stress is the same as that of normal stress. Stress is simply the applied force per unit area, whether it's acting perpendicular or parallel to the area.
Sir, your video is not moving.
In the beam by shear force.
what?
Here the deformation will be something like this. The
Not
object
moving
is
for me.
stretched
Video
to
is.
some
क्या बोला?
वीडियो सर चल रहा ही नहीं जैसे
वीडियो पे
वैसे है आवाज आ रहा है तो
मेरा
तब
तो
था
सुन रहा है.
हाँ सर नहीं चल रहा है मेरा लिए पता नहीं अलग के लिए चल रहा है कि नहीं
What about others? Is it going on?
Sir, not clear.
Sir, it's lagging.
And it's not moving the video.
It's not very clear, sir.
The audio is very bad.
Yes.
Is it? Wait. Okay, now I'll download it and show it to you. Actually, this is the basic concept. Let me try it once more.
आपका सर आवाज भी अभी क्लियर नहीं हो रहा है
अभी नहीं हो रहा है आवाज
आपका हाँ क्लियर नहीं हो रहा है इट्स ब्रेकिंग
अभी भी ब्रेकिंग हो रहा है
या सर इट्स ब्रेकिंग
ओहो वेट ये नेटवर्क का बहुत प्रॉब्लम चल रहा है अभी कैसा है
Crack है sir, crack.
या नाउ इट्स
अभी भी क्रैक है
No, it's fine.
Okay, just see it. If it is cracking again the video, I'll stop it. Okay.
Okay sir.
In physics, what really happens when we cut a cake using a knife? In physics, we could say that the cake experiences stress. Usually when we cut a cake, we hold the knife straight and apply the force perpendicular to the surface area. So can you guess what type of stress this is? It is normal stress as the force is acting perpendicular to this area. But what about these cross-sectional areas of the cake? The area on top is not the only area that experiences stress. As we pierce the knife in, this cross-sectional area experiences stress too. It doesn't look too obvious, but it does experience stress. We can also see that the force is not perpendicular to this area. It acts parallel to it as we are pushing the knife straight down. If the force acts parallel to the surface, it exerts shear stress. This stress tries to push the two surfaces away from each other and hence results in plastic deformation. So this is the basic difference between normal stress and shear stress. Normal stress is where the force is acting perpendicular to the area of contact, while shear stress is the force that acts parallel to the area. Let's take another example which explains shear stress better. Here's a beam and assume that it's fixed at its base. If we apply normal force to this cross-sectional area, then we know that the stress experienced by the beam will be normal stress, which is simply given by F over A, where F is the applied force and A is this cross-sectional area. This will result in a normal strain in the beam, which is given by delta L over L, where delta L is the change in length and L is the original length. Now suppose that we apply a force in this direction, parallel to area A. Again, the beam will experience some stress, but this time it will be a shear stress. The equation or formula for shear stress is the same as that of normal stress. Stress is simply the applied force per unit area, whether it's acting perpendicular or parallel to the area. What about the deformation in the beam by shear force? Here the deformation will be something like this. The object is stretched to some extent. Note that the beam is fixed to the base, so this cross-sectional surface will remain where it is, whereas the cross-sections above it will all get displaced to the right by increasing amounts. Now look at the maximum displacement here. Let's call it delta x. We know that this length is L. It's perpendicular to this. Also notice that there's an angle formed here. We can call it theta. With this information in place, let us define what shear strain is. Shear strain is simply equal to tangent of theta. Yes, shear strain is simply the tangent of this angle. But what is tan theta? We know that it's the opposite side over the adjacent side. Here, the length of the opposite side of theta is delta x, and length of adjacent side is L. So it's equal to delta x over L. So that's how shear strain is defined. Length of the deformation at its maximum over this perpendicular length.
Is it okay now?
Yes, sir.
Yes, sir.
I'll give you the link in this chat only. Yeah, you just mark this link. This is just the basic, okay? So that your concept is clear. Did you understand today's class? Is it okay for all of you? Apart from these network issues?
Yes, sir.
Yes, sir.
Okay. So if you have any doubt, you just ask me, okay? In the next class, you just ask me.
Sir, Tidas.
It is in the ERP only, that notes. Did you see the notes?
No, sir.
Just check it out. If you don't find it, then tell me. You got
Yes,
it
sir.
now in portal? You'll get the notes now. Okay. Is it okay?
Yes, sir. Yes, sir.
Yes, sir.
It is in the portal itself.
Sir,
Bolo.
sir, can you solve the problem of the behavioral management, sir? I have already talked
Which
about that, but sir, ma'am is also not sure about that. Huh?
Which subject?
Behavioral management.
Management. How can I solve management problems?
Management.
मैं तो इंजीनियर हूँ, मैं कैसे मैनेजमेंट का प्रॉब्लम सॉल्व कर सकता हूँ?
No. Actually, ma'am, no. According to her routine, is not clarify for.